Okay, so this is the continuation after our first video in which we were talking about parallel lines and some definitions were established. The first theorem is, after that, the first theorem is if two parallel planes are cut by a third plane, then the lines of intersection are parallel. So let's try to translate this into a figure, into a picture. All right, so we have this one right here on the left side. And if you notice, we have two planes, right? The purple ones. Okay, so let's call this one M and let's call this one N. Okay, so plane M and N are parallel. All right, and if you notice, we have the blue plane. Let's call it P. The blue plane, it's intersecting the two parallel planes. All right. To summarize and the notation, let's call line AB L and line CD Q. Okay. So we need to prove that if these two are parallel and the blue one, plane P, is cutting the two planes, then the lines AB and CD are parallel, or basically L and Q are parallel. Okay, so we already know that we need to establish some statements. So statements, and some reasons for our statements. Okay, so our first statement, it's the given. It says if two parallel planes are cut by a third plane, so plane M, it's parallel to plane N, right? And let me put some different colors to this so we do not confuse some of these notations. All right, so parallel plane M is parallel to plane N, all right? And also are cut by a third plane, okay? So also we have that plane P intersects plane M, okay? And we have the plane P also intersects plane N, this one right here, okay? So plane N, okay? This is given, all right? This is given. Okay, number two. We know by a postulate that the intersection between two planes, it's a line. So we know that line AB or line L, that is the same thing, also exists, right? So line L, it's MP and also in M, right? Look at right here. She's in M and MP, okay? All right, so this, it's by a postulate that says that a line is the intersection between planes, all right? So by the same reason, we can now say, or we can say that line Q, it's in P and in N. And let me show it right here. So line CD, that is the same as Q, it's in N and also on P, all right? Okay, so by the same thing, by the same reason, by that postulate. Okay, so if line 2 and 3 are true, then we know that line L and Q are coplanar, all right? Why? By definition of coplanar. They are on the same plane, plane P. By definition of coplanar, all right? So 5, lines L and Q do not intersect. Why not? Because the planes are parallel, right? It says two parallel planes, all right? So planes are parallel. Planes M is parallel to N, so they do not intersect. So they are coplanar, they do not intersect. So by definition, we now know that line L, it's parallel to line Q. This is by definition of parallel lines. All right. Okay, so remember that in the previous video, we established that if two lines do not intersect and they are coplanar, they are on the same plane, then they are parallel. Okay, so this is the proof of this first theorem for parallel lines.